Good evening to all of you. So last year we have seen the force exerted on the plane surface, which is immersed in the liquid. That was about the plane surface. So one problem we'll do regarding the plane surface. So what we see, just some bit of recap, we'll do it. What is the formula we are getting from it? What is the force value? Where the force resultant force is acting. The point name is the center of pressure. So what is the location of the center of pressure? Everything we have find out last year. In terms of the depth from the free surface, we'll see. Or you can see according to your coordinate system. So X and Y, you fixed some coordinate, and along with the coordinate, you can find out this thing. So we'll come back to the slide. So regarding the plane surface, is this kind of the plane surface, the formula you are getting here. There's the force exerted, the total force. Actually, it's a system of the parallel force. How it is like that? Because in this age, the pressure is a less. So here some less pressure is, less force is acting over the area. At here, the depth is more, so pressure is more. So that's why here more force is acting. More amount of force is acting. Here, slightly less amount of the force is acting. In here, the slightly less amount of the force is acting in such a way, but it's a number of system of the parallel force we have seen last year. It's a system of the parallel force. There are a number of parallel forces acting over the plate in this way. So on the plane surface, the number of parallel forces acting, and what is the force value? The net force, total force acting over the body. That is the rho, density of the fluid, G, area of the plane surface, and HC. H is the height of the centroid from the free surface. If the C point is at here, so what is the height from the free surface? This is the height. So that is the HC. From the Varignan's theorem, we could be able to see this total resultant force is acting over a point. The point name is the center of pressure, E. P is the point for the center of pressure. So hence we are getting this, the height of the center of pressure, the depth of the center of pressure from the free surface should be equal to the HC plus that is the second moment of area about the axis passing through the centroid. So IC or IG, you could be able to same thing it right. IG, better to write it cavity, and this IG. That's one. As it is, there is an angle. It creates one angle. This angle is a theta. So one sine component, sine square component will come sine square theta. The derivation already we have seen the last class. Sine square theta, AHC. This is the formula you are getting here. Like this. These two are the important things. Force, and from the free surface, the location of the center of pressure. These two things. Now, one problem we'll see regarding this topic, and after the problem, we'll come back to the curved surface. What are the forces acting over the curved surface? Because you will see that the curved surface, this kind of the parallel force will not be present there. So here you are getting the system of parallel forces. It's a system of parallel forces. In the curved surface case, we will not get such a system of parallel forces. So first we do one example. This is the one gate 2013 it comes. One hinge gate is there. is the gate. The length of the gate is the 5 meter. The length of the gate is given to you 5 meter. So L is given to you 5 meter. 5 meter the length of the gate. It is inclined with the horizontal at 30-degree angle. It creates with the horizontal at 30-degree. So this depth, what is this depth of this here? This depth is, if you take this as H, so you could be able to write it down. If you see here the triangle, so that is the H, the L. If this angle is a 30-degree, so this angle will of course a 30 degree. This angle will be of course a 30 degree. So H divided by L is sine 30. So you're getting the H value as 5 sine 30. Sine 30 is a half, so 2.5 meters. That you are getting here. 2.5 meters. Now, what are the forces acting over the body? First, we calculate the force, then we calculate the location. Here, what is the demand? You just understand the problem what they are wanting to do. Because of this water here, because of the water, here some force is acting over it. How the force is acting? The force is acting in this, over the plate. One force is acting. This force is acting the point. This point name is the center of pressure point. This point is the center of pressure. On the other way, this another force is acting here at centroid. At centroid location, another force is acting here. That is the weight. W. Due to the mass of the gate, some weight is acting. Now these two forces are balanced. The moment due to the force F and moment due to the force W, the resultant moment about the hinge will be 0. Then only this gate will be at equilibrium condition. So the ultimately condition is that W, whatever the moment creating by W, so W into the distance. What is the distance from the hinge? This distance. This is the distance. W into this distance. What is that? If this is H, so centroid always at by half position it will be acting. So if the centroid will be always at half position, it will be acting. So 5 total length if the 5, the centroid location in this way, so 2.5 meters. Along the plate, it is 2.5 meters, centroid location. So this is 2.5, and this is a cos component, 2.5 cos 30. So W into 2.5. So this is a distance. This distance we are bothering about it here, because this angle is the 30 degree. So this by this is a cos 30. So 2.5 cos 30 is the moment by W. What is the rotation? Sense of the rotation? Sense of the rotation is in this way, clockwise, because W here creating one clockwise. Here the F, if you consider the F, the force, total force. So total force, the distance from the hinge is YP. You can take it as this YP. This is a YP. Distance. If you take is along this axis, you are taking the Y. If you take its Y axis. and opposite is the x-axis. If you take it this along the plate, y-axis if you are considering. So this is the y. Or you can say, in this way you can say, or yp instead of the yp you can say the hp. So yp is the location. So here it is hp. Height. Here it is the hp. So this is the hp divided by sin theta. So yp you can be able to write it hp divided by sin. So two way you can find it. Either yp or hp divided by sin. The same thing. Sense of the rotation. Sense of the rotation is the anti-clockwise. So one clockwise moment, one anti-clockwise moment. They will nullify each other. And from here, we could be here. If you have to calculate first, then you have to calculate what is the weight. After getting the weight, it is easy to get the mass because weight is equal to m into g. That is the sense of the problem. So here, what is the force is acting over the plate? The force is acting rho g hc into a. What is the rho? Here, water is there, fluid is the water. So 1000 into 9.81. 1000 into 9.81 into hc is here because h is equal to 2.5. So hc will be definitely 1.25, 2.5 by 2. Because here hc location, the location of the hc, the total h is the 2.5. So in the mid position of it, centroid, so 1.25 into this area. Area is the 5 is the length, into width. Width is taken as the unit width because length and the other portion we cannot see perpendicular to the paper, that is the into 1. So this is the force is acting over this. If you calculate, this value will get nearly 61.312 kilonewton. Because by divided by 1000 if you do, so kilonewton will come here. So a value you are getting here. Now the second task is to find out the yp or hp. So if you are going to find out the yp, then yp is equal to yc plus ig ayc. If you're interested to find out the hp, so hp is equal to the two ways you can get it. ig sine square 30 degree divided by ah. This two way. You can take any one of it. So yc is already 2.5 because along this c is at 2.5 from here. C is at 2.5. Here the P location. So 2.5 plus IC. IG. So what is the second moment? Because actually it looks like a rectangle. If you see the plate, it is looking like a rectangle. That is the width side. Width is the 1 meter and this side is the 5. It is cutting in this way. That is the axis. About the axis you are going to finding out the second moment. So IG is going through the centroid. So IG is equal to 1 into 5 cube. It's a rectangle, so 1 into 5 cube by 12 divided by the area. Area is the 1 into 5 and YC is equal to 2. If you do the calculation of this problem, your value will become nearly 3.33. If you go for the HP calculation, you're divided by 2 will come, because HP is nothing but YP sin 30. Whatever the calculation you will do, HP is nothing but YP sin 30. Now, so any one procedure you can follow in this kind of the problem. In terms of the center of drift or along the axis, along the plate. Now we directly come to the formulas. Here, the W you can write it down M into G, mass into acceleration. 2.5 root 3 by 2 is equal to 61.3125 kilonewton. In terms of the kilonewton, you can convert it into the Newton also. So 10 to the power 3 in terms of the Newton into Y2. So YP is equal to 3.33. If you do the calculation, your G value is already 9.81. So M will become nearly 9622 point something. So your obviously answer will come as in this problem. So that is the way. That is the way to find out such kind of the problem. Now we'll come back to the force on the curved surface, which is immersed in this liquid. So let you take here a curved surface like this way is a curved surface. So in the curved surface, you take one elemental area. So in the curved surface, first thing is here we are not getting the system of parallel force. So no system of parallel force. So no system of the parallel force. Because over the curved surface, the force may be like this way. These forces are not parallel forces. Here you are taking the first x, y, z. We have to finding out the x-axis, y-axis, z-axis. These three axes is here. Now we are going to take one elemental area, small elemental area. This is the elemental area dA. We are interested to take one small elemental area dA. Elemental area. Differential elemental area. So depth of this area, the depth of this area from the free surface. Now your XY plane, you are considering your XY plane is the free surface. Is the free surface of water. Water or any liquid, XY plane is the free surface. And along the Z, you are getting the depth. Along the Z axis, you are getting the depth. So at the depth of Z, let you take at the depth of Z, small z. So elemental area from the XY surface, that is the Z depth. Depth is at Z. Z is the depth of the area, depth of the elemental area from free surface. This portion you have to understand properly because fluid statics is most important. The concept you have to grip it first. So then everything will be easy. Now this elemental area making angle with the x-axis is alpha, is making angle with the y-axis is beta. and making angle with z axis is normal. This elemental area making angle with x axis alpha, y axis beta, and z axis normal. This is the case. Now here the force is acting. Some force is acting due to the fluid pressure. Some force is acting F. dF, small elemental area is acting over it. So dF definitely having three components. One component is along x-axis, dfx. One component along y-axis, dfy, and another component along z-axis. So if you resolve this df, so three component you will get, and this three component, needless to say that dfx is equal to df cos alpha, dfy is equal to df cos beta, and df z is equal to df cos alpha. This is the way to find it. Now let us say at z location, some pressure is acting over it. What is the pressure? Because the depth here, we are considering z is the depth. So what is the pressure is acting over the elemental area? The pressure is acting over the elemental area. P is equal to, the gauge pressure is equal to rho gz. No doubt about it. Rho gz. That is the pressure is acting over it. Gauge pressure. So df is equal to, so df is equal to rho gz into elemental area. So df, we are considering df is equal to rho gz into elemental area. So dfx is equal to rho gz dA cos alpha. So dA cos alpha. Next, dfy. First, we are considering dfx and dfy. It will give you better understanding. Rho gz dA cos beta. What is the cos alpha and cos beta component? This is coming. So, if any area you are projected on the plane, the area is like this way. If projected on a xy plane, so it will be in this way, projected. If you project some area over the plane, so it will come under the cos component of the corresponding angle. This area makes with the angle with x-axis alpha. So if you project the same area over the xz plane, so it will come, the area, remaining area, projected area will come dA cos alpha. This is the projected area. So dA cos alpha and dA cos beta, these two parts. So dA cos alpha, so dA cos alpha is the projected area. If you project this area over the xz here, if you project here in this plane, if you project here in this plane, same area, if you project here, it will be looks like in this way. So what will be it? dAx. dAx is the projected area. We project the area dA on yz plane, so it will be looks like. Now let you consider it's just a plane surface type problem, because as you project on two-dimensional case, so it's like a plane surface, a curved surface. If you project on a two-dimensional plane, so It's just a plane surface problem. So plane surface problem, you have seen the previous way. If you project here, so what is it? dAx area. So what is the force is acting over it? If you consider, so the distance is the z is given to you from the free surface. So the force, just I am verifying this thing, the force dF will be dFx will be rho g area, before area, the jet centroid. Centroid is at here because very small area. Centroid is at jet same way. Jet dAx. So dAx is dA cos theta. You are get back in this equation. So a curved surface problem, we are converting it in a plane surface problem in this manner. So what is the total force along this x-axis? Fx is equal to, if you do the integration, if you do this integration in this way, so rho g is out of the integration, rho g is come out of the integration, z is equal to the zc. So total, where is the centroid? You have to search for it, and zc into ax. Ax is the projected area, the total curved surface you projected on yz plane. That is coming the ax. If you total this curved surface, if you project here, so it will be, if you project here, then it will get it. On the similar manner, fy, on the similar manner, fy also you are getting same way. So I'm not repeating here, the same way you will get it, rho g z day. Day is the dA cos beta is dA, because this elemental area makes angle with the y-axis, the beta. So the cos component of the beta will give you the projected surface. So here it is coming as a rho g zc. So these two forces okay, Fx and Fy. What is the remaining? Remaining is the Fz. That is the most important thing. Because these two forces are vertical force. This Fx and Fy are horizontal force. The horizontal forces. Now we are considering about the vertical force, the most important. So horizontal force is on the projected surface. So if any curved surface, if you project over a plane, you will get the horizontal force. In this plane, if you the same curved surface, if you project on this plane, on this plane, if you project this thing, you will get the horizontal force. The same thing, same curved surface in this plane. In this plane, if you project it, you will get the another horizontal force, Fx and Fy. But the most important calculation comes in the Fz. So that is the, so dFz. If you think about the dFz, is an important thing. Please try to concentrate here. dFz is equal to rho gz dA cos gamma. Same way here, like this way. dF, we are putting the value of the dF. Already we are getting it previously. So this same surface, if you project here, the same surface if you project here, xy plane, it will comes dAz. That is nothing but is equal to dA cos gamma. Okay, same surface you are projecting. So that is equal to rho gz dAz. So dAz is the area, and Z is the, so this is the Z. DAZ and this is the Z. So what you are getting is the volume. Area into Z, this volume you are getting. You see here, this volume you are getting. DAZ into Z. So DAZ into Z is the volume. Volume of what? One volume you are getting. Area into depth. So this is the volume into density, the mass, into G. Mass into G is the weight. Weight of what? So FZ, FZ. Weight of what? D rho G. That is the discussion here. Weight of what? Weight of the liquid supported by the curved surface up to the free surface. Weight of the liquid supported by the curved surface up to the free surface. So over the curved surface, if above there is some liquid up to the free surface level, the total weight of the liquid is acting as a vertical force, and vertically it is downward force. It's a vertically downward force. It is acting at the centroid of the fluid. This force will be act on the centroid of the fluid, or center of gravity of the fluid. So this is the scenario in here. So horizontal force over the, just you project it, you are getting the horizontal force in both surface. YZ plane, if you project it, you are getting one horizontal force. If you on the XZ plane, if you are projected, you are getting another horizontal force. And in case of the vertical force, you have seen that the weight of the liquid supported by the curved surface up to the free surface level. That is the interesting consideration you are getting here. Similarly, you can see here, if it is a curved surface, we are considering this a curved surface. Here is the curved surface. Okay. One curved surface. The simple way I am telling it, just you force balance. In this calculation, I am telling it in the very simple manner. This is a curved surface. So what is the horizontal force? The horizontal force is, if you project the curved surface, just it's a two-dimensional view, we are not seeing the perpendicular to the plane. The horizontal force will talk about in this way. If you project this curved surface in this way, in this plane, so it will be looks like in this way. The different color I should use, it will better understand. So here, if you project this curved surface, it will be looks like in this way. Other side is the unitary side. Is the projected surface. So over this surface, so it's a plain vertical surface. There's no doubt about it. It's a plain vertical surface. So over this surface, what is the force is acting? That's the horizontal. Now it's a, we convert this curved surface for the case of the horizontal. In the case of the horizontal force, we convert this plane surface, a curved surface, to plane surface by projecting by projecting it on a plane. So this curved surface we project on this plane and we are getting this force. So now it is a very simple thing. What is the force is acting over it? You will get it. What about the vertical force? The vertical force will gives you the weight. The previous discussion I'm telling the vertical force is the weight of the liquid column supported by curved surface up to the surface. So there is a liquid. This liquid is supported by this curved surface. This liquid is supported by the curved surface. So from here, if you draw one perpendicular line, vertical perpendicular line up to free surface, that is this. From here, from the end, this is the one end of the curved surface, let you take the name A, this is the B. From the A, you draw one dotted line up to the free surface. Okay. And from B also the same way, one vertical line you draw up to the free surface. The total weight of the liquid, is nothing but the vertical force. In the zone, how much amount of the fluid or liquid is there, liquid column is there, the total weight of the liquid comes as a vertical force over the curved surface. That is the consideration we are getting from the previous derivation. So that's all. And this weight is nothing but, if you're getting it, so what is, see here, so this is the volume of the liquid column into density of the liquid into G. And the weight is acting downwards from the centroid. So this liquid, the centroid is at here, might be, so downwards. That is nothing but the vertical force is acting. So W is equal to Fp. That is the consideration. And horizontal force over this plane. So this is the only projected surface here. So projected surface, there is a centroid. Centroid is at here in this position. There is centroid. So height of the centroid, if you're getting from the free surface, you're able to get the free surface HC. So horizontal force will gives you rho G HC into projected surface. Is if the area was, this area was capital, here it is A already, we have written it. So small a, right here, small a area. So small a, if you project this small a in this manner, so small a P, projected area. Now this area is the small a. So this way we are getting find out horizontal force and vertical force in this. Now some consideration if the curved surface is like this one. So three consideration we are making here. So this is one curved surface. This is one curved surface. This surface just we discussed a few minutes back. In this way, the curved surface is there. So horizontal force here, the depth is the same. Let you guess here also H. All case it is H. Height is H. In three cases, if you see the horizontal force, So horizontal force, how to finding out here? Horizontal force is, if you project the area like this way, is the projected area, vertical surface it is looks like. Here also, if you project this thing, vertical surface. Here also, if you project, there. You project here, it's like this. That is a projected surface. So all the cases, the same horizontal force is the same. If you consider the horizontal force, FH, for all the cases, a rho, G, projected area, AP, into H by 2. Centroid, H by 2. All the cases, same. But in these cases, the vertical force are different. Horizontal force is same for all the cases. But FV is different for the different cases. First case, so already it is the free surface up to here. So in this column, the liquid column, the weight of the liquid column here, this liquid, this much of liquid, this much volume of the liquid is supported by the curved surface. This much volume. So weight of this liquid up to the free surface will gives you here. So if you consider here the free surface, FV, if you consider here FV, it will comes in this manner. So weight of this liquid. If it's a semicircular area or something else, whatever the value is, maybe circular or parabolic, but this weight you have to search for it. And in this case, the weight is acting vertically downwards. This force is downward force in this case. In this case, the force is a downward force. If you think in a different manner, it will be clear. If you see here, just over the surface, the force is acting in this way. Pressure, due to the pressure, the force is acting in this way. Non-parallel force. This all are not parallel, non-parallel. So the net force, the inclination towards downward. So net force, what is acting here, the net vertical force, what will be acting here, that will be also downward vertical. Easy to understand. In here in this way, here whatever the force is acting in this manner. In here, so here if you see the resultant force, so net vertical resultant force will be act here, FV here, as a upward force. Because the net force, if you take the component, all component will become in this. So net vertical force, here is the net vertical force is acting upwards. In this example, the net vertical force will be. So what is the value of it? Previous case, this much of liquid was supported by this curve. We have seen it, or in this example. For here, how much? What is that values? So in this example, you have to consider this volume. You have to consider this volume. And this volume is not supported by the curve. Actually, it's a imaginary type of the concept is coming here. What kind of the concept? Imaginary concept, because the curved surface replaced this much of liquid. So due to this, just like a buoyancy concept, we'll see the next topic. Due to this, the opposite, the force is total is acting, telling in the opposite direction. So this much of amount curved surface in here, this much of amount the liquid, the weight, and it is displaced by the curved surface. It is considering in this way. And net, that's why net particle force, the fluidic concept, net particle force is upward. But from the pressure also you could be able to understand that is the net force will be always upward in this case. Here it is the half portion is upward and half portion is downwards. This is the most interesting problem you will see. In here, if you consider here, the upper half portion is supported by this liquid, this much of liquid, this much volume of the liquid. So upper half portion is supported by this much of liquid. This is the upper half portion. What about this portion? This portion is supported by, because this curve. So because of this, the force is acting in this, for the upper half portion, the force, if you consider only upper half, so A, B, C. So on the AB surface, FV, first FV1 is downwards. And this is the, let you take some B. And what is the area? If you consider the area and other side, so that is area of A, B, B. This is the area. If you consider some volume, if you consider rho and G, this is the force. That is in the surface AB. For the surface BC, if you consider only surface BC, so BC surface, if you're considering only this surface BC, so from B, if you draw the perpendicular line, it will meet at D. From C, if you draw a perpendicular line, it will meet at A. From B, one perpendicular line up to free surface. From C, one perpendicular line up to A, free surface A. So here, the vertical force is nothing but the area of BCAD into the same width into rho. That is the vertical forces acting. Direction of the vertical force, it should be upwards. Because this curved surface is displaced the amount of the liquid. This curved surface is displaced the amount of the liquid. So it is because another way, if you see here, the pressure force due to the pressure is acting in this. So the net force is acting upward side. In this zone, the force is acting in this way, so net force is downwards. That is another analysis. Say V1 is the downwards, if V2 is the upwards. So net vertical force here, FV2 minus FV1, because FV2 is more. So what is this area? So this total area minus this much. So area of semicircular area you are getting here, ABCA is the semicircular area into W and width into rho g. This will gives you the net force, and which would be vertical in direction. It will be vertical in direction. That is the consideration. So this kind of the surface, if you are giving it to you, so it is enough to get it. So if this kind of the surface you are getting it, you are given, so it is enough to get this area, the semicircular area. So let you see here, this h, already we are telling it. So pi 8 h square. Pi by 8 h square into width will gives you in this problem, that is upwards. In this kind of the problem, this is the h. So this area FV is equal to, this is the quarter of, so pi by 16 h square W. Actually, h is here radius, not diameter. So, sorry, it's a pi by 4 h square. Pi h square is the total. So pi by 4 h square into W into rho g. That is also upwards force. In here, supported by this surface, is nearly the same value will come in the downward direction. Here, the force will come, the same value might be in downward. So in this way, this kind of the problem you can